Hello again, welcome to Unit 11, and welcome to Chapter 3. The rest of the quarter basically will be spent in Chapter 3. Chapter 3, we expand the language pretty dramatically, making it substantially more complicated and powerful, able to say a lot more than the language that we had previously. So in this unit, or in this video, excuse me, I'm going to talk about the grammar of our new language, and then in subsequent videos in this unit talk more about what the formulas and sentences in this language mean. So, why are we expanding our language at all? We need a little bit of motivation. So consider the following English arguments. We have every person is mortal. Socrates is a person, so Socrates is mortal. This is a valid argument. However, we interpret person, mortal, and Socrates. If the premises are true, so is the conclusion. Again, we say every whale is a mammal. Every mammal is warm-blooded, so every whale is warm-blooded. This is another valid argument. However, we interpret whale, mammal, and warm-blooded. If the premises are true, the conclusion is as well. Or last, some novelist is a genius. Every novelist is lonely. Some genius is lonely. Again, however we interpret the premises, however we interpret novelist, genius, and lonely, the conclusion is true if the premises are. However, we cannot symbolize these. The only symbolizations we can provide of these arguments so far produce invalid symbolizations. None of these have complex propositional structure. In no case do we have in the English, a sentence with parts having as other sentences as parts and then connected with sentential connectives. We have predicates, names, sort of every and no and some words, is. But each of these just has to be symbolized so far as PQR and PQ therefore R, and that's not a valid argument. So we need to enrich our language. We need to make the grammar more complicated. We need pieces of our language to symbolize things like person and mortal and is and Socrates. And we also need pieces of the language to symbolize words like every and some. And that's what we're going to do. We're going to have we're going to make our language more complex so that it can symbolize these in ways that the symbolization of the English argument is also a valid argument in the logical language, so that we can capture the logical structure of these more complicated English sentences. So we call the language that we get to predicate logic or quantificational logic or quantificational calculus because the main things we're adding are predicates and quantifiers. So I'm going to talk about all the new symbols that we add, however. The first, we have a new category of terms, and there are two kinds of terms. There are names, and these are names in the logical language, and the symbols that are names are little a through little h. And the English equivalent of names are just English names, like Bob and Henry and Jose, and so on. We also have variables in the logical language, and the variables in the logical language are little I through little z. And their English equivalent, they have two. One is variables as they're used in mathematics. So like in an algebra class, you say, okay, in the equation x plus 7 is 0, solve for x. So x there is a variable. And then pronouns like it, he, she, also often function like variables do. We'll talk more about that as we go. We have a category of predicates, or predicate letters, and these are big A through big O. So big A through big O are predicate letters, big P through big Z, capital Z, are sentence letters. And these are like verb phrases, or verbs. So runs is running, and so on. Again, we'll discuss these more. The last category is the category of the quantifiers, and we have two quantifiers. We have the existential quantifier, which is backwards E, and it means something like something is such that. And we have the universal quantifier, which is an upside down A, and it means each thing is such that. And the idea with the symbols is the existential quantifier says there exists a blah blah blah. So exists starts with E, so we have a backwards E as our existential quantifier. A universal quantifier can be heard as saying all or any, and those begin with A, so we have an upside down A. So okay, what about our grammatical rules for these new symbols? So remember first that a term is a name or a variable. So a predicate letter followed by a term. So capital A is a predicate, X is a variable. So capital A, small x is a predicate letter followed by a term. Capital O is a predicate letter, small a is a name, so we have hence a term, and so capital O, small a is a predicate letter followed by a term, and so it's a formula. I'm using the word formula here instead of sentence. I'll talk about that later. For now, when you hear formula, you can think sentence. There's going to be a difference, which will be explained subsequently, but for accuracy's sake, I'm just going to say formula instead of sentence for now, and then explain the difference later. Getting into the difference right now is not worth the time. If we have a quantifier, the backwards E or backwards A, then we have a variable, so little I through little z, and we have a formula, then we can form a new formula by writing quantifier, variable, old formula. So existential quantifier Y formula, or universal quantifier Z formula, those are also formulas. So the quantifier phrases, so the quantifier is just the backwards E or the upside down A. Quantifier phrases are a quantifier plus a variable. And the quantifier phrases attach to formulas in just the way that the negation does. It says, oh, there's a formula, I just go on the front of it. It doesn't add parentheses. Parentheses come just from what they've already come from. Conditionals, biconditionals, conjunctions, and disjunctions. And we have all of our old rules. So sentence letters are formulas. If you have a formula, the negation sign followed by the formula is a formula, and so on for the conditional, biconditional, conjunction, and disjunction. So those are the rules for forming formulas. Quantifiers are the new logical symbols, and so they're called quantifiers because they have to do with quantity claims. We make quantity claims with them. We say everything is a certain way. That's a claim about, everything is a frog. That's a claim about the quantity of frogs. Or I say something is a frog. That's a claim about the quantity of frogs as well. So they're called quantifiers because they make quantity claims, or we use them to make quantity claims. There are many other quantifiers in natural language, like most, many. We're going to use just these two, the universal quantifier and the existential quantifier. You want to make sure you're following how they work as we go along, and that's going to take a little while to build up to a full understanding of how they work, but it's really important that you understand how they're being used, and that will require understanding how variables and predicates work, because quantifiers interact with variables and predicates, most importantly. As I said, we're talking about formulas or formulae instead of sentences, or in addition to sentences. As it turns out, it's going to turn out that every sentence is a formula, but they're formulas that are not sentences. So sentences are a particular kind of formula. What's the difference between a formula? What specific kind of formula is a sentence? Talk about it later. For now, we're going to have this category. I'm just going to be talking about formulas. When you hear formula, you can think sentence, and for now, that won't be terribly wrong. Once the distinction gets explained, then you'll want to follow it. So let's talk a little bit about the interpretation of our new predications. Predication being a predicate letter followed by a term. So let's say that A, being a name, symbolizes the name Bob. And suppose that F symbolizes runs, and FA symbolizes Bob runs. Note that though the order, subject-verb order is reversed, right? In English we have the subject first and then the verb. In the logical language we have the verb first and then the subject. If F symbolizes is running, then FA symbolizes Bob is running. If F symbolizes is a runner, FA symbolizes Bob is a runner. So, okay, that's pretty straightforward. So how do these things work? So we can call, if we have a predicate letter followed by a term, we can call that an atomic formula. An atomic formula is a formula that has no formulas as parts. So a sentence letter is an atomic formula. It doesn't have any parts, and so none of its parts are sentences. A predication like DH is also an atomic formula because while it has parts, the predicate letter capital D and the name lowercase h, neither of those are sentences. So again, it's an atomic formula because none of it has doesn't have any sentences as parts. So in that way, it's actually kind of like real atoms. The physical atom is composed of protons and neutrons and electrons, so it has parts, but it doesn't have atoms as parts. Okay, so how does DH work? Well, D is a predicate, and what predicates do is they classify. They're true and false of things. So when we interpret a sentence letter, we assign a truth value to it. To interpret a predicate letter, we say here are the things it's true of, here are the things it's false of. So D could be interpreted as true of all the things that dance and false of everything else. H is a name. What do names do? They refer to particular objects. So to interpret a name in our language, we need to say what does it refer to. So we could imagine that H refers to Henry. And then a predication of a predicate letter followed by a name, that's true if and only if the predicate is true of whatever the name refers to. So if H refers to Henry and D is true of all and only things that dance, then the predication DH is true if and only if Henry dances. If and only if Henry, so we have the name Henry, what does it refer to? Henry, the guy, and the predication is true if and only if Henry is in the group of things that the predicate is true of. Okay. What about a predication with a variable instead of a name? So suppose we interpret F as runs. Then Fx is going to mean something like it runs, or he runs, or she runs. F is running, if that's what F means. Then Fx means it is running, or he is running, or she is running. F is runner means it, or he, or she is a runner. So variables work like our first sort of way to understand them is to think of them as symbolizing pronouns. It's going to be more complicated than that, but that's a good first pass. So let's do a little bit of grammar. Suppose we have a string FA, then is this a formula or not? Well, the first symbol is a predicate letter because it's a capital letter between A and O. The second symbol is a name because it's a lowercase letter between A and H. And so we have a predicate letter followed by a name. So this is a predicate letter followed by a term, and so it is indeed a formula. Capital G, little l. Capital G is a predicate letter because it's a capital letter between A and O. L is a variable because it's a lowercase letter between I and Z, and so this is again a predicate letter followed by a term. HE, a capital H is a predicate letter. E is a name, so this is a predicate letter followed by a term. So all of these so far are formulas. Little a, big F, first symbol is a name, second symbol is a predicate letter, but they're in the wrong order, so this is not a formula. Big P, little z, so we have, in this case, big P is a sentence letter, little z is a variable, so this is not a formula, and in particular not a predication because it's lacking a predicate letter. We would need a capital A through capital O in the place where the capital P is. Capital F, capital N. First symbol is capital F, that's a predicate letter, so good so far. Second letter, capital N, is a sentence letter, so this is not a predication because it's lacking a term, and so it's not a formula at all. Okay, what about the grammatical rules for the quantifier? So remember, if we have a slightly different way to say it is this. If we have a variable and a formula, then we can write existential quantifier, variable formula, and get a new formula. And if we write universal quantifier, variable formula, then we get a different new formula. So we read this as sum x fx, and it means something is such that it is a frog, or just more briefly, something is a frog. Excuse me. For all x, fx means each thing is such that it is a frog, or more briefly, everything is a frog. One last comment, one comment about complex formulas. You can embed them, quantifiers can be embedded within one another. So if we start with hx, that's a formula. X is a variable, so we can say existential quantifier x hx, that's a new formula. Having two formulas, we can put one in the antecedent fx, the other sum x hx in the consequent of a conditional and put parentheses around them, and we get a formula. And we can put a quantifier on the front of that. And notice that these two quantifiers for all x and sum x have the same variable in them. That's fine. There's nothing that says, if you look at the quantifier rules, it just says quantifier variable formula. It doesn't say anything about does the variable already occur in the formula or not. So that's the end of this video. I'm going to do some parsing problems in the next video, and then talk more about how to interpret the formulas of this language and do some English symbolization.